بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 6.2 Area. So the aim of this section is to introduce the concepts of total area and net signed area between the graph of y is equal fx and the x-axis on the closed interval a to b. Then to calculate total area and net signed area, introduce and calculate the area between two graphs in the xy plane. So first let us start by definition 6.2.1, which is the definition of the total area. If y is equal f of x is continuous on a closed interval a to b, then the total area A bounded by its graph and the x-axis on the interval is given by A is equal the integral of absolute value of fx, where x is from a to b. So to evaluate the total area between the graph of fx, which is continuous function in the closed interval, and the x-axis, so the area will be equal integral of the absolute value of fx, where x is from a to b. So for the total area we evaluate it, we take the absolute value of x. But there is another definition which is called net area. When we evaluate the integral of fx from a to b without absolute value, we said this one is net area. But for the total area, we have to add the absolute value sign. So for example here, if we want to evaluate the area between the graph of y is equal f of x and the x-axis on the closed interval a to b. If you find if you write it like integral of fx where x is from a to b, so will be the net signed area. It will be a2 minus a1. But if you want to evaluate the total area, you have to take the absolute value of x. Because if you take the absolute value of fx, then once you evaluate the area, it will be a2 plus a1. Because this minus will be up here, it will be positive. So that's why here we get the total area, which is a1 plus a2. Where f of x can be redefined like minus f of x if fx less than 0 and fx if fx greater than or equal to 0. يعني إذا نريد نجيب التوتال area لازم ناخذ الابسولوت فاليو للانتجرال للفانكشن، لأنه نحن نعرف إنه الفانكشن أحيانا تكون موجودة above الإكس أكسس وأحيانا تكون below الإكس أكسس. فإذا كانت موجودة above الإكس أكسس فبتكون بوزيتيف، لكن إذا موجودة تحت الإكس أكسس بتكون الناتج بي النيجاتيف، على أساس نضمن إنه التوتال يحسب لنا التوتال area بحيث إنه يحسب هذا النيجاتيف بيعطيها إشارة موجبة، بالإضافة إلى إنه هذه البوزيتيف بتصير نفس الشيء موجبة. إذا لازم ناخذ الأبسولوت فاليو. إذا نريد نحسب التوتال اريا مرة ثانية لازم ناخذ الأبسولوت فاليو of x. لكن إذا نريد نحسب النت ساين اريا ناخذها بدون absolute value of fx. So here we have an example. Find the total area bounded by the graph of y is equal x cubed and the x-axis on the closed interval minus 2 to 1. So here we need to find the total area. So that's mean we need to take the absolute value of the function y. So here we see that the interval is from minus 2 to 1. We see the graph of y is equal x cubed is negative when x is in the interval from when y is in the interval from minus 2 to 0, and it is positive when it is on the interval from 0 to 1. So that's why we need to take, for evaluating the total area, we need to take the integral of absolute value of x cubed from minus 2 to, where x is from minus 2 to 1. We see here that minus x cubed is negative in the interval minus 2 to 0, so we take the absolute value of fx is equal minus x cubed when x is between minus 2 to 0. And f of x is equal x cubed, which is positive in the interval from 0 to 1. So now we redefine this absolute value of x cubed and we get the integral is equal. We substitute into integral. We divide it into integral minus 2 to 0 and 0 to 1. So for minus 2 to 0 we'll take minus x cubed, and from 0 to 1 we'll take x cubed. So the integral of minus 2, the integral of absolute value of x cubed from minus 2 to 0 plus the integral of absolute value of x cubed from 0 to 1. For this one absolute value of x cube, we see that it is negative on the interval -2 to 0. So we'll take minus x cube plus. For x cube in the interval from 0 to 1, it is positive. So we take here the integral of x cube. Now the integration of minus x cube will be minus 1 over 4x power 4. And we need to evaluate it when x is between -2 to 0. The integral of x power 3 will be 1 over 4x power 4, and we need to evaluate it from 0 to 1. So now if we replace x by 0, we'll get here 0 minus, replacing x by -2, we'll get minus 16 over 4 plus, replacing x by 1, we get 1 over 4 minus, replacing x by 0, we get 0. So once you evaluate this one, you will get it is 17 over 4. So 17 over 4 is the total area between the x-axis and the graph of y is equal x cube on the interval from -2 to 1. Some of you will say that, okay, once I evaluate the integral, so I get here, it is, for example, I evaluate the integral of x cube, then finally I will take the absolute value of the result. No, this will not be the case, because it will be different value. يعني شي منكم مثلا بيقول انه طيب عادي انا بجيب الناتج مع الانتجرال اوف اكس كيوب، الناتج اخر شيء اللي بيطلع لي باخذ الابسولوت فاليو للناتج. يعني اذا كان الناتج اخر شيء يطلع نيجاتيف باخذ الابسولوت فاليو ماله بيطلع لي بوزيتيف. لا، هنا ما بتركب العملية هذه. ليش؟ لأنه لو أخذنا اللي هي آخر شيء اللي هي الابسولوت فاليو، هنا بيصير عندي نيجاتيف وهذه بتصير بوزيتيف. فلما أجمع مثلا هنا ماينس 7 وهنا مثلا 2، فماينس 7 بلس 2 بيطلع لي ماينس 5. إذا الناتج بيطلع الابسولوت فاليو في ماينس 5 which is 5. لكن بالمقارنة لو كانت هذه مثلا ماينس 7 وهذه مثلا 2، أخذنا الابسولوت فاليو من البداية بيطلع 7 بلس 2 9، ف9 الحين تختلف عن ال5. أساس كده ما يصير ناخذ الابسولوت فاليو آخر شيء، لا، ناخذها من البداية للفانكشن الأصلية، نحدد متى هي بوزيتيف ومتى هي نيجاتيف، وعلى أساسها نكمل اللي هو الانتجريشن. Then here we have example number 2. Find the total area bounded by the graph of y is equal x squared plus 2x and the x-axis on the closed interval -2 to 2. So here we have the graph of y is equal x squared plus 2x. We need to find the area which is between the x-axis and this graph on the -2 and 2. So this area here and this one is here. We see this graph x squared plus 2x is negative on the part from -2 to 0. So from -2 to 0, we have the function y is equal minus x squared plus 2x. And for the interval from 0 to 2, we have this function y is equal x squared plus 2x. So once you evaluate the total area, you will take from -2 to 0 is negative, the function is negative, and from 0 to 2, you will take the function is positive. So now the total area is given the integral of -2 to 2 absolute value of x squared plus 2x d of x. From -2 to 0, we have the function absolute value of x squared plus 2x is equal minus x squared plus 2x. And for the interval from 0 to 2, we see that this function is positive, so we'll take x squared plus 2x. Now we just integrate this one minus x squared plus 2x. This will give us minus 1 over 3x cubed minus integral of 2x will be x squared. Then we need to evaluate the integral from -2 to 0 plus. The integral of x squared will be 1 over 3x cubed plus integral of 2x will be x squared. And we need to evaluate the integral from 0 to 2. Now replacing x by 0 here we'll get 0. Replacing x by 2 we'll get 8 over 3 minus 4 plus. Here we have 1 over 3 multiplied by 8 plus 4. So this will give us 8 over 3 plus 4. Then replacing x by 0, get it is 0. So once you evaluate these two terms, you will get the value is equal 8. So the total area between the graph of y is equal x squared plus 2x and the x-axis on the interval from -2 to 2, it is given by 8. What if we want to find the area between or area bounded by two graphs? For example, if you have two graphs, y is equal f of x and y is equal g of x, and you want to evaluate the area between these two graphs. For example, if we take the area between y is equal f of x and x is equal to 0, it will be all this area. And between y is equal g of x and x is equal to 0, it will be this part, which is the white one. Now, if we want the area between f of x and g of x, we will take the area of f of x to the x-axis minus the area of g of x minus the x between the g of x and the x-axis, and we will get this part. So for this we have in the definition 6.2 area bounded between two graphs. If f and g are continuous function on the closed interval a to b, then the area A of the region bounded by their graphs on the interval is given by A is equal integral of absolute value of fx minus g of x, where x is from A to B. Here, since we are talking about the area between two graphs and we don't know which one is greater than the other one or which one is upper than the other one, we will take the absolute value between these two functions, where the absolute value of fx minus g of x is equal g of x minus f of x, where g is the upper graph, or fx minus g of x whenever f is the upper graph. So for this case, here we have the upper one is fx, the lower one is g of x. So the area of this graph will be the integral of fx minus g of x, where x is from A to B. If in the case we have g of x is the upper one, so we'll swap, it will be g of x minus f of x. يعني على أساس إن نجيب الاريا between two graph نحدد أول شيء من اللي موجودة في الأعلى ومن اللي موجودة في الأسفل. طبعا هنا نحن عندنا absolute value of fx minus g of x. كيف نكتب absolute value of fx minus g of x؟ إذا كانت الf اللي هي موجودة في الأعلى والجي موجودة في الأسفل، إذا هذا عبارة عن absolute value، هذه عبارة عن f minus g. لكن لو كان العكس، مثلا الجي هي اللي موجودة فوق والf اللي هي موجودة تحت، إذا بيكون هذا absolute value of f minus g of x عبارة عن g of x minus f of x. إذا على أساس أجيب الاريا between two graphs عبارة عن ال a is equal integral of absolute value of x minus g of x, where x is from A to B. بعدها أحدد من اللي موجودة في الأعلى ومن اللي موجودة في الأسفل، طبعا على حسب الانترفال. يعني مثلا في الانترفال هذا from A to B عند الf هي اللي موجودة أعلى دائما في هذا الانترفال، فهنا الابسولوت value of f minus g بتصير عبارة عن f minus g.